In this lesson, we're going to be using Gaussian Elimination Method to find the solution of this system of simultaneous linear equation. The first we're going to do here now is to form the coefficient matrix from the left hand side of this equation. When we do that, we're going to have the coefficients of this x will make the first column, which is 1, 2, and 3. And the second column will be made up of the coefficients of y, which is going to be -4, -3, and 2. And the third column will be made up of the coefficients of z, which is 2, 2, and -1. Then we multiply this coefficient matrix by the variables, which is x, y, and z, then equal to the constants, which is 6, 9, and 4. The second thing we are going to do now is to form the augmented matrix by including these constants into this matrix, but we're going to place it at the right hand side of this coefficient matrix. So when we do that, we're going to have 1, 2, and 3. We have -4, -3, 2. We have 2, 2, -1. Now we now include the constants, which is equal to 6, 9, and 4. Then let's close this matrix. Now this is where the work starts. So we are going to be focusing on this 3 by 3 coefficient matrix. So we're going to be reducing it to upper triangular matrix or row echelon form. In that, we're going to make these two 3 and these two to be 0, like the position of these elements are all going to be 0 for it to be in upper triangular matrix or row echelon form. So in trying to achieve that, we're going to be performing series of row operations. Now we're going to start with this row 2 and row 3. To make this 2 here 0, the row operation we're going to perform is row 2 minus 2 row 1, right? Because 2 minus 2 times row 1 here is 1 is equals to 2 minus 2, which is equals to 0, right? This will make this position 0. Remember, we're also going to apply this row operation to all the elements in this second row. Now to the third row, the row operation we're going to do here is row 3 minus 3 times row 1, alright? This is because row 3, which is 3 minus 3 times row 1 is 1. So this is equals to 3 minus 3 times 1 is 3. So 3 minus 3 is equals to 0. So this operation here, we convert this 3 to 0. And then it will also affect all other elements in this third row. So let's go ahead and perform those operations. So our row 1 did not change. So I have 1 minus 4, 2, and then 6. Now for this second row, we have row 2 minus 2 row 1, which is 2 minus 2 times 1, which is 2 minus 2. This will give us 0. And for this second element here, we have -3 minus 2 times -4, right? So I have -3. Minus times minus is plus. 2 times 4 is 8. So 8 minus 3 is equals to 5. So we're going to have 5 here. And then for this third element here, we have 2 minus 2 times we have 2 here. So which is equals to 2 minus 2 times 2 is 4. 2 minus 4 is equals to -2. And then for this 9 here, we're going to have 9 minus 2 times 6, alright? So this is 9 minus 2 times 6 is 12. 9 minus 12 is equals to -3. So we're going to have -3 here. So the same way we are going to perform this operation row 3 minus 3 row 1. When you do that on all these elements, we are going to get 0, 14, -7, and -14. I'm just doing this for the sake of time. If you do this, if you compute this, you're going to get all these elements here. So the next we're going to do here is to divide this row 2. This is row 2. We're going to divide it by 5 just to make our simplification simple. We're going to have 1 here just as we have 1 here. So that will make our computation simple. And this row 3, we're also going to divide it by 7 because 7 can divide 14, 7 can divide negative 7, and then 7 can divide negative 14. So we're going to use 7 to reduce them. So we now form the next matrix, which is 1, we have negative 4 and 2, so we have 6, then here we have 0, 0 divided by 5 is 0, 5 divided by 5 is 1, then we have negative 2 over 5, then we have negative 3 over 5, and 0 divided by 7 is 0, 14 divided by 7 is 2, minus 7 divided by 7 is minus 1, minus 14 divided by 7 is minus 2. Now the next operation we're going to perform here is we want to make this 2 here to be 0, and doing that we're not going to make use of this row 1 again. We're going to make use of this row 2, right? If you make use of this row 1, it's going to affect this 0 here, and then it will not be 0 again. So I'm going to make use of this row 2, which is this one here. So the other operation we're going to perform is row 3 minus 2 times row 2, right? Because this is interpreted as 2 minus 2 times row 2 here is 1. So that 2 minus 2 times 1 is 2 is equal to 0. So this element here will automatically be 0. So here row 1 and row 2 didn't change, so let me rewrite them. We have 1, negative 4 and 2. We have 0, 1, negative 2 over 5. And we have 6 and negative 3 over 5. So here we already have 0 here because this one did not change. Then performing this row operation, we have 2 minus 2 row 1, this one will now be equal to 0. Then we have this one will be negative 1 minus 2 times this negative 2 over 5, which is negative 2 over 5. So this is going to be negative 1 minus, this is minus times minus is plus, 2 times 2 is 4 over 5. So if you perform this operation here, we're going to get minus 1 over 5. Now for this negative 2, we have negative 2 minus 2 times negative 3 over 5, or negative 3 over 5. So if you perform this operation here, we are going to get negative 4 over 5. The next we're going to do now is to multiply row 3 by 5. So we have 5 times row 3. So we're going to do this to clear this fraction of negative 1 over 5 and negative 4 over 5. So if you multiply them by 5, we're going to clear this fraction. Also note that we have 5 here for second row and then 5 here. But if you multiply this second row by 5, this one here is going to be affected, and we don't want to change this one for easier simplification. Alright, so when we do that, our row 1 and row 2 did not change. So let me just write them. We have 1, negative 4 and 2. I have 0, 1 and negative 2 over 5. Then we have 6 and negative 3 over 5. We have 0 here, then this one will be 0. Then 5 times negative 1 over 5 will be equals to negative 1. And then 5 times negative 4 over 5 is going to be equals to negative 4. Now that we have achieved our aim of making this matrix to be in row echelon form or upper triangular matrix, let's return these constants to the right hand side just the way they were before. So we're going to have 1 minus 4 and 2. Then we have 0, 1 and negative 2 over 5. And we have 0, 0 and negative 1. So we now write our variables, which is x, y and z, then equal to this constant now to the right hand side, which is 6, negative 3 over 5 and negative 4. Now let's multiply this matrix and this column matrix. So 1 times x is equals to x, then minus 4 times y will be minus 4y, 2 times z will be plus 2z, then equal to 6. Now for the second row, we have 0 times x will be 0, 1 times y is equals to y, then minus 2 over 5 times z is equals to minus 2 over 5 z, then equals to minus 3 over 5. For the last row, we have 0 times x is 0, 0 times y is 0, minus 1 times z is equals to minus z, and this is equals to negative 4. Now if you look at these three equations, this is equation 1, equation 2, equation 3. So from these three equations, let's find the value of x, y, and z. We're going to start from equation 3 because it is the easiest one to do. So we're going to divide this by negative 1, so that this and this will cancel, this and this will cancel. Our z will be equals to 4. So we have found the value of z. Let's plug in this value of z into this equation 2 to find the value of y. We have y minus 2 over 5 times z is 4, then equal to negative 3 over 5. So we have y minus 2 times 4 is 8 over 5 equals to minus 3 over 5. Let's take this minus 8 over 5 to the right hand side. The sign is going to change to plus. We have y is equals to minus 3 over 5, then plus 8 over 5. Since they have common denominators, we just add the numerators. So this is minus 3 plus 8, which is equals to minus 3 plus 8 is 5, then over 5. This is equals to 1. So we have that the value for y is equals to 1. So let's plug in the value of z and y into this equation 1 and then find the value of x. X minus 4. Now y is equals to 1 plus 2, z is equals to 4 equals to 6. So x minus 4 times 1 is minus 4, plus 2 times 4 is 8 is equals to 6. X minus 4 plus 8 is plus 4 equals to 6. So x is equals to 6 minus 4. I have that x is equals to 2. So x is equals to 2. Now these are the solution to this question. Let me just write them out. I have that x is equals to 2, y is equals to 1, and then z is equals to 4. So this is the answer to this question using Gaussian Elimination Method. Thank you for watching. Please remember to subscribe to my YouTube channel, turn on the post notification bell, so that each time I post a new video, you'll be the first to watch it. Also don't forget to share with your friends. See you in my next video.